Hello everyone, I'm Sipulot, and in this video I'm gonna showcase the feature set of my PCBs. Please note that some of the features are shared between all types of PCBs that I produce, namely MX, EC, and Hybrid, while some others are specifically tailored towards the EC and Hybrid PCBs. In case some of the features are not present when you try to access them on your board, it might be possible that the PCB does not support them at all. It is also possible that the firmware is out of date. In that case, I would suggest you to flash the newest firmware and try again. If this step fails to showcase the specific feature that you're looking for, I might suggest to reach out through Discord or the email support. The first function that I'm gonna showcase is the custom indicators. I have a customized version of the EC980C as a showpiece where we have 3 LEDs indicators. Right now they are all turned on as an indicator of layer 0. How can we address them? Once we load VIA, you can go into the Indicators tab and you will be greeted with a list of the available indicators, namely left indicator, central indicator, and the right indicator. And you will also see that for each indicator we have a bunch of features that we can customize. The first one is the enable function, and as the name implies, it allows us to enable or disable the LEDs completely. In this case, if I turn off the enable left indicator, the left indicator turns off. If we turn it back on, the LED is turned back on again. We can also control the brightness of each LED independently, as well as the color. Now, if we want to customize the functionality of the LEDs, we can do so by clicking on the drop-down menu of the function tab. Right now I have layer 0 as a showpiece, but you can access a bunch of customization such as caps lock, num lock, scroll lock, and also indications for different layers. To validate that the LEDs now work as a layer 0 indicators, I'm gonna press the specific key that I have customized as a modifier layer to jump into layer 1. As long as I have the modifier key pressed down, the LEDs are turned off. They all turn off at this point because all the LEDs have a layer 0 function. We can customize this behavior going into the function tab, and as a showpiece, I'm gonna address the left indicator as a caps lock indicator. You will notice that now the left indicator is no longer turned on because I don't have caps lock turned on. The other LEDs maintain their respective function, so if I press the modifier key, they still act as a layer indicator. But now, if I press the key combination that I have assigned for caps lock, the LED will turn on and it will stay on regardless of the layer because now this LED is tailored to caps lock indicators. These settings are maintained at boot of the board and even if the power turns off. The second feature is a gaming feature and it's called SOCD. In order to access it, click on the Advanced Features icon and you will be prompted into the SOCD menu. You can see that by default, the feature is disabled for all the key pairs, and this is intentional because I do not want people to get kicked or banned from games because of the feature being active accidentally. Please note that this feature may be banned or prohibited to be used in certain scenarios of games, for example Counter-Strike, in competitive and online scenarios. In order to enable the feature, simply choose whatever key pair you want to enable and click on the drop-down menu. We have various modes that we can choose from, namely last priority, neutral, first key priority, and second key priority. As an example, we're going to select last key priority and see that we have some new customizations that pop up. Every key pair works in the same way, so this explanation will be tailored for the pair number 1, but it's true for all the other key pairs. Please note that every key pair is independent of one another, so you can have the first key pair enabled and the other ones disabled, or you can also have different modes for key pairs. The thing that you will focus on now is the key customization, namely the first key and the second key. The SOCD function works on a pair key based, so two keys that work in tandem to deliver the desired functionality. If you want to customize the key that is tailored to the specific pair, remember that the two keys that you see here, namely A and D, are not a synonymous of the actual physical layout of the board, so key A and key D in this specific location, but rather where that key code is assigned. So if you have A assigned to spacebar and D to the enter key, if you try to use this feature with these two keys, it will not work. It will work with spacebar and enter. So keep that in mind. If you want to customize the key assignments, simply click on one of the keys that you want to change and enter the desired key. For example, we're going to use B and D. So now the two keys that are bound to this feature are B and D. Note that these changes and the modes are persistent in the keyboard memory, so when you unplug the board and you replug it in, the settings will be saved. Now onto the explanation of the various modes. We have last priority, neutral, first key priority, and second key priority. The last key priority basically gives priority of actuation to the last key pressed between the two keys that you specify in the pairing. So if we have the A key pressed down and we press the letter D now, A gets deactivated and D gets activated. The particularity of the last priority mode is that as soon as the second key gets released, the first key gets reactivated. So if we press down A, press down D, A gets deactivated, but as soon as we release D, A gets reactivated again. And same goes the other way. If we press down D first and we press A gets activated, D is deactivated, but as soon as A gets released, D gets activated again. As an example, we can go in the key tester and see the behavior in action. You can see now I press down A. If I press down D, D gets activated, A gets released, and as soon as I release D, A gets activated again. And it's true also for the opposite. D is pressed, I press A, D is released, I release A, D gets pressed again. The second mode is called neutral, and it's similar in the first half of the behavior of the last priority, but in this case, when I press the other key, the first key gets deactivated, and as soon as I release the other key, no reactivation is performed. So we can see the behavior now. I press down A and then press D. We will see that A now gets released. Okay. The other two modes, first key priority and second key priority, is basically just a way of saying that there is no reactivation and neutrality, but the priority is given to the first key or the second key. By first key and second key, in this nomenclature, we refer to the first key that we specify here and the second key that we specify here. When I was talking about last priority and neutral between first and second key, I was referring to the first key being pressed rather than the key sequence that we have in this menu. As previously mentioned, you can disable all the features and you can have different modes for different key pairs. So we can have last priority for pair number 1, we can have neutral for the other one, and all of these modes are living together so that you can use all of them at the same time. Please note though that if you try to set the pairs, for example, pair 1 to one mode and pair number 2 to another mode, but you have the same key assignments, this might cause unintentional behavior and it might lock the board in a permanently key press state. So in order to address that, you should unplug and replug your board, and if the issue persists, it is advised to flash the firmware to basically reset the board at a known state. Now we will go into the EC and hybrid specific features, the first of which is the calibration. The calibration tab will be covered in a dedicated video explaining the procedure. So the important thing that you need to know is that the calibration feature is available when in EC mode, and it mainly consists of a toggle switch for the bottoming calibration, where by toggling the calibration on, the board will not respond to any key press, but it will instead acquire the key states of each key, and to exit calibration mode, you simply untoggle the calibration. Now let's talk about actuation modes. We have two available actuation modes, APC and rapid trigger. APC is a simplified version of a classical on-off switch, but you can customize the actuation and the release levels. The default mode for the EC PCBs that I produce is APC mode, with a actuation and release level that is roughly at half of the key press. It is important that the actuation level is always higher than the release level, and the left side of the sliders is towards the lower end and the right side is towards the higher end. So you'll see here that the actuation is higher than the release. In case you crisscross the two sliders and you apply the changes, it is highly suggested to unplug the board immediately to avoid random key presses being sent over to your keyboard and PC. And if the issue is so severe that you cannot feasibly change the sliders, it is suggested a reflash to bring back the board in a neutral state. The way you customize the sliders is simply by clicking and dragging the controls, and this customizes the actuation and release levels. To be sure that it is applied to the board, after you do your changes, click on Apply and Save Changes, and this will save the changes on your board and they will be persistent on the keyboard. Now let's talk about the rapid trigger mode. The rapid trigger mode works in a similar way as the Hall effect keyboards that you're used to, the gamer features, where you have a bunch of feature set and values that you need to care about. In this implementation, we only have 3 values that we need to pay attention to. One is called the initial dead zone offset, and the remaining are actuation and release offsets. The initial dead zone offset is the point of the travel before which the keyboard does not recognize any key press regardless of the keyboard state. So in this case, the key slider is halfway to the key travel. So this means that supposedly, let's say this is 2 millimeters in the key travel, anything before 2 millimeters of the key travel is not considered as a key press. Once you reach the threshold of half the key travel, you will enter the rapid trigger zone. And in this zone, 2 other values kick in to determine what is the state of the key. The actuation offset and the release offset. The one thing to be noted is that the initial dead zone offset slider considers the entirety of the key travel. The left side being the resting position and the right side being the bottom out effectively. The actuation and release offset does not tie logically to the full key travel, but rather to a smaller subset section based on the current key position. This is why we have 0, 100% in this nomenclature, and we have smaller another type of nomenclature, namely 1 to 255 for the actuation and release offsets. So as a recap, The initial dead zone offset is the point at the key travel at which the rapid trigger becomes functional and we start to treat the key press as a key press, and the actuation and release offset are offsets from the current position within the rapid trigger zone. The actuation offset is a value that, while you're into the rapid trigger zone, indicates the amount of key press that is treated as still being pressing down from the current position of your key. The release offset, while in the rapid trigger zone, is the amount of release that is needed to treat the up motion of your keyboard as a release event, so unregister the key press that you're performing. It is highly suggested that you keep the actuation and release offset to a value roughly like this, and to not go too much to the left side of the slider. This is because if you set the actuation and release offset in rapid trigger mode to a too of a small value, it might be possible that because of the sensitivity of the scanning, you might have false actuation and releases even though you're relatively static in your key travel. And again, to apply the changes, you simply click on apply and save changes, and that will save your changes on your keyboard. Now onto a hybrid specific feature. We will swap keyboard. The hybrid PCBs share all the feature set that we have regardless of the models with the EC only counterpart, but it changes the name of the menus from EC tools to hybrid tools, and it has one critical option in the actuation tab, namely the switch type. By default, I ship the PCBs that are hybrid into EC mode, and this allows you to go into the calibration, change the EC specific actuation modes, so APC and rapid trigger. But if you are building your hybrid board in MX form, at this point, before even pressing any key, you will go into the actuation tab and switch from switch type EC to switch type MX. When you do that, the keyboard enters a normal MX keyboard mode where you would have a static actuation and release point determined by the specific key switch that you have. Note that now the calibration tab might not be available in some specific versions of certain PCBs. Other versions are still accessible, so if you have the menu for calibration accessible even though you are in MX switch type, please do not perform any type of calibration in this mode.